Today we're going to be talking about why does my soda taste flat? Our duration is 10 minutes, our subject matter and its interactions, our grade is middle school, and our NGSS standard is MSPS 1-1. Our learning objectives for today are students will be able to describe how a gas dissolves in water, students will be able to describe how temperature affects matter interacting, and students will be able to describe how molecules transform under pressure. Matter interactions MSPS 1-1 states students will develop students who demonstrate understanding can develop models to describe the atomic composition of simple molecules and extended structures. Our science and engineering practices involve developing and using models, disciplinary core ideas, PS 1-A, structures and properties of matter. The two forms of matter we're going to be talking about today are gas and liquids. Our cross-cutting concepts include scale, proportion, and quantity. First question is, what are the bubbles in my soda?
Here, I have a water bottle. You can't really see much, but it's a normal water bottle until I shake it up. And then what happens is we see all the bubbles coming out of water. We hear that hiss when we open it, just like we would if it was a soda. Now, the reason that this happens, I wonder why. Think about it. Why would water bubble?
So take some time right now to form a hypothesis. Why would water bubble? What can we do to water in order to make it bubble? What are the bubbles and what are the water made out of? What molecules are they made out of? Take a minute to form a hypothesis. Now we're going to explain, how can a gas dissolve in water? The bubbles that we saw were gas, specifically CO2, and the water we know as H2O. Our water molecule involves one oxygen and two hydrogen molecules, and our carbon molecule involves one carbon and two oxygen. So when we use pressure to introduce our gas into our water, we are forcing these two to combine. The polar ends of the water molecule are attracted to the opposite polar areas of the carbon molecule. How can a gas dissolve in water? The reason that the gas dissolves in water is because the carbon molecule plus the carbon dioxide molecule and the H2O molecule combine. However, unlike when we dissolve sugar in water, this structure is not as securely attached. So what happens is it can detach through pressure or temperature and time. So, as I stated, pressure, temperature, and time can affect how these molecules interact. So my question to you is, how does temperature affect how quickly carbon dioxide is released? Let's take a minute to think about it. What soda goes flat first? A soda that is cold or a soda that is hot? Take a minute to form your hypothesis. What soda do you think would hold on to its carbon dioxide faster? A hot one or a cold one? We're going to test out this theory with a balloon race.
Alright, so we're going to be having a balloon race. What's going to happen is I'm going to put the balloons on top of the bottles, and then we're going to give them a quick shake and see which one fills up the fastest. Start with hot. And then we're going to go with cold. And we can already see that the hot bottle is already filling up. So in order to make sure that these stay on, we're going to take some tape. Tape it to the side. So we can see that while the cold water is rising gradually, the hot water has already inflamed. It's already swollen up all the way. So in the time that it took the cold bottle to swell all the way up, the first one's already full. What does this tell you?
So, our hot water won the race. It was able to inflame its balloon faster than the cold water. What does that tell you about how the carbon dioxide and the H2O molecules interacting? Take a minute to form one hypothesis. As the temperature of the water increases, the solubility decreases. The warmer the water, the more the carbon dioxide comes out. That's why if you have a hot soda and a cold soda, the hot soda will get faster sooner, and the cold soda will stay bubbly and carbonated for a longer period. Now it's time to use what you know. We're going to watch an experiment that the Mythbusters conducted, and then we're going to add a variable of temperature. So after watching the experiment, think, would this experiment be different if the temperature of the soda was colder? What if it was hotter? Let's watch the video.
The Mythbusters are going to have a blast. The most common theory about what's going on in this reaction between the candy and the soda is what's called nucleation. Basically, the idea is that the surface of the candy is covered with microscopic pits and lots of more surface area than you can actually see. And each little pit, each little corner provides what's called a nucleation site, or a place where a carbon dioxide bubble can form and escape.
Look at a Mentos close-up, and it's like the surface of the moon. And that might be the candy key. Drop one in cola, and every tiny crater provides a site where a CO2 molecule can change to gas. Because Mentos are so pitted, the theory is that millions of CO2 bubbles are formed in a very short space of time. And because the candy sinks, and this rapid release of gas happens at the bottom of the cola, you get that famous fountain. To test this nucleation theory, they're going to start with a control. One regular mint Mentos dropped in soda water. And sure enough, it gets the bubbly party started. Now, to do a comparison.
These two candies are made by the same manufacturer, and as far as I'm aware, even using the same process. But the colored version of this actually has a glazing over it. It's a wax coating or a sealer that inhibits the nucleation process that the other one achieves quite readily.
The shiniest surface should lower the nucleation sites, meaning less of an immediate eruption.
That's not doing anything more than the wall of the plastic bottle itself.
Sure enough, with the smooth Mentos, there ain't no whiz with the fizz. The Mythbusters can say they finally cracked the case of the candy and cola cascade.
So now that we watched the experiment, how would the experiment change if the temperature of the soda water was colder or hotter? If we add a Mentos into hot soda, would it have the same reaction as a Mentos into cold soda? Why or why not? Write down your observations and theories.